Alright, this is Chemistry Basics video number 2. This one will be a little bit shorter, so let's dive right into it. Talking about solubility a little bit in class. In your white powder lab, you discussed that. So what is solubility? Solubility is simply the ability of something to dissolve in something else, right? So as you see in the picture down on the bottom right, we have the solid, we call that the solute in chemistry, and we have the liquid, we call that the solvent in chemistry. Most of the time your solute's going to be a solid, most of the time your solvent's going to be a liquid, and it's usually going to be water. So if something is soluble, it means that the solute can dissolve in the solvent, right? A lot of S words there. You see the picture of the Alka-Seltzer as well, dissolving in the water. We could say that is soluble. The Alka-Seltzer is soluble in the water. That's a physical change. Why? Because a lot of times we can reverse the solubility of something. When we dissolve something, a lot of times we can simply reverse it and we can get it back. A good example is salt dissolved in water. If we want to, we can leave that salt water out in the sun for a day or so. And what we're going to be left with is just grains of salt, NaCl. That's called evaporation, and that is a reversible change. So, solubility. Okay, most important thing of this lesson is matter, right? We've talked about matter is anything that has mass and takes up space or has volumes, but we can break this down even further. We can break this down into this little hierarchy. I really like this picture. I wrote this on the board in class during notes. We have two different types of matter. We have a pure substance and we have a mixture. And in the next few slides, we're going to break down what a pure substance is and talk about elements and compounds, and what a mixture is, and talk about homogeneous mixtures and heterogeneous mixtures. So, great picture to come back to, great thing to kind of memorize and put in your mind when we're talking about matter and how we classify matter. Okay, so let's start with pure substances. Pure substances are elements at its most simple. Elements are the simplest form of matter, meaning they can't be broken down any further, right? So if you look at the periodic table of elements, those things can't be broken down any further. Gold, iron, zinc, the things you know on there, those are the simplest forms of matter possible. And so we see that there. Sodium, carbon, chlorine, all these are elements that we find on the periodic table. Can't break them down any further. But we can also have compounds. And what's a compound? It's made up of two or more elements, and that's chemically combined. So let's write down a few examples of elements. And actually, let's go back up here and write down a few examples of elements and compounds. So elements, we know hydrogen is an element on the periodic table. Calcium is an element on the periodic table. What else? Helium is an element on the periodic table. All these are found on the periodic table, the simplest form of matter. Compounds are made up of two or more elements, and if you have to know kind of any term for this, it's going to be chemically combined. So, some examples of compounds that you are probably familiar with. Good old H2O, water. CH4 is methane, and notice you have different elements here, and we'll talk about later on in the year how they chemically combine. CO2 is what you're breathing out right now. These are all compounds, two or more elements that are chemically combined. Okay, mixtures on the other hand. We have two types of mixtures. Homogeneous, sometimes called homogeneous. You can say any word, potato, potato. Homogeneous mixtures have the same composition or makeup throughout. What does that mean? I think of Kool-Aid, a really good example. Kool-Aid, you can't see the little bits of powdered Kool-Aid once you mix it up, right? You mix it up good enough that all that powder disappears, and we would call that homogeneous. It's the same throughout. Another good example of that would just be any type of soda, coffee, Even the water we drink sometimes, and I'll put a little star by that or an asterisk because that's not all the time, but the water we drink has vitamins in there, it has minerals, it has chlorine, there's other stuff in water other than just H2O. We would call that homogeneous mixture because it's got the same composition or makeup throughout. The other one is called, excuse me, heterogeneous. And we see the root words on both these. Homo, the root word of this, is simply the same, and hetero means different. And we use these two terms in society today. So homo, same, hetero, different. And heterogeneous, we think of the composition and the makeup as not the same throughout. What do I mean by this? This fruit salad's a great example. So I have strawberries, I have pineapple, I have grapes, I have blueberries. It is not the same makeup throughout. I can pick out each one of them, those things. I always think of salsa, another good example, right? It's all salsa, but it's certainly not the same throughout. The composition, the makeup is quite different. All right, a few ways to separate mixtures we'll see in lab this year. Filtration's the first and easiest. So what do I mean by that? Filtration allows you to separate mixtures. So specifically those of the heterogeneous nature, but you see this setup that we have here. Filtration allows particles through a membrane. We see a filter in this case. It keeps some in and others out. A good example of this for all you biology people, right, is a cell. We call a cell a semi-permeable membrane. It lets some stuff in, but other stuff it doesn't. Distillation. We won't use this year, but we'll talk about it a little bit. Distillation uses different boiling points to boil off and separate parts of a mixture. So this setup's really cool. Say we have some sort of substance in that flask right there. We can boil this off, and depending on the temperature, it will rise, and some of it will flow down this apparatus, and we can boil off different parts of a mixture depending on the temperature. And then lastly, chromatography uses differing polarity. We'll talk more about that word later. And solubility, again, how stuff dissolves to separate mixtures. We won't talk much about that this year, but we will discuss it every now and then.